Okay, so today we're gonna try to calculate the derivative of x squared uh, of the function f(x) equal to x squared by definitions. Okay, so we have the function here f(x) equal to x squared, and so we're gonna apply uh, the definition of a derivatives, which is the f prime of x is just a limit of delta x. This is delta x come to 0 of f of x plus delta x minus delta x. Uh, that's the numerator, and in the denominators we're gonna divide that whole expression for delta x. Okay, and as the limit of as the process of taking the limit, we're not gonna let the delta x to come to 0. Okay, so that's the by definition the derivative definition of a derivative, and we want to apply that definition to the function f(x) equal to x squared. Okay, now so when we replace with f(x) with uh, x squared, so on the first term we're gonna replace everything, that we're gonna replace x with x plus delta x. So we got x plus delta x squared, and for f(x) we just gonna have x squared. Okay, so x plus delta x squared minus x squared all over delta x. I'm gonna take the limit of delta x to 0. Okay, now we're gonna expand this square, x plus delta x squared. We got x squared plus 2 delta x times x plus delta x squared minus x squared and divided by delta x, and still we're gonna take the limit of delta x to 0. Next, we want to simplify the numerator. So you can see here we have x squared here and minus x squared here, so they are cancelled out. So in the numerator we are left with 2 delta x times x plus delta x squared, as you can see here, and in the denominator you still have delta x, and then the process of taking the limit of delta x to 0 is still the same. Oh, so as you can see, this is the indeterminate form of the limit, because if you replace delta x with 0 here, you're going to have 2 times 0 times x plus 0 squared over 0. So that's 0 over 0 form, indeterminate forms, so you cannot calculate it by normal derivatives strategy of replacing numbers. So in this case, we have to factor out the delta x from both the numerator and the denominator, and then we're gonna reduce those delta x variables, because one in the denominator, one in the numerator, so they are reducible. So what we are left with is the limit of delta x to 0 of 2x plus delta x over 1, because delta x has been reduced. So well, in this case you just have to replace wherever you have delta x with 0. So what we left with is 2x over 1. So the answer is 2x. So therefore the limit of the derivative of f(x) equal to x squared is 2x for any x.